Hi, this is part 2 on section 4.2 area, and what we're doing is taking a look at computing the area under the curve and how we go about that. And the first thing we're going to do is we're going to set up rectangles of width going across, and what I have here is I have three pictures. The first picture over here, let's make sure I have a writing tool here, because occasionally I forget to do that, and I think I have in this case. Right here I have a concave up graph, and these are called left corner rectangles, and you can see, or left Riemann sums are going to eventually be called, and you can see that the left corner is what's touching the curve, okay? And because this function is concave up and I'm touching on the left side, what I have is I have an under approximation. And you can see I have, and I'll abbreviate approximation, because I've got some empty spaces here that aren't being accounted for. Over here now what I have is I have a right cornered, the rectangles are touching the same curve, and the curve is concave up. But I am touching, and I have a little bit of overlap by these rectangles, and so what I have is an over approximation. And it's not dependent on whether it's left-handed or right-handed. It's in combination of the concavity. So if you take a look here, I have a curve here, and this is obviously concave down, and it's right cornered. And again, this is an under approximation. And I'm going to try to draw the same curve here. Let's see if I can do that. Okay. And if you notice, I have no rectangle down here, so there's this whole gap on this one right here to the left of here with where I have the right-handed, where that's not accounted for. So what I'm going to have is I have 1, 2, 3, 4 rectangles. I'm going to have 4 rectangles here too. So I have this point, I have this point, I have this point, and I have this point. But this time I'm going to have left. So I'm going to start with this left point, and I'm coming over and I'm going down. And then I'm going to start with this left point, and I'm coming over and going down. I'm going to start with this left point, and I'm coming over and going down. And now I'm going to have 4 complete rectangles because I didn't have this last one. And so this area right here that I'm kind of putting a little check mark is an over approximation. All right. Now, what I'm going to do here is I have the same equation. Here's 0, and here's 2. And I have a parabola, and it's going down, and it's 5 units up, so it's going to start here. And if I put 2 in here, I'm going to have a negative 2 squared, that's a negative 4, plus 5 is 1, so I'm going to end up here. So my graph, right here I have a little vertical line going straight up, and my graph is coming from here down to that point. And I'm going to do it again here. Let's see if I can replicate this. Come up here to about 1. This is right here, and I'm going to come something like that. It's not nearly as nice. And what I'm going to do here is I'm going to have a left corner, and I'm going to I'm going to put 5 I think 5 rectangles in here. Well, actually, let's go with 5. So I have 1, 2, 3, 4, 5, and my first ones will be to the left. Oops. That wasn't very good. Let's see if I can draw a better rectangle. So far they're not doing very well. And so you can see, since I am concave down, the left ones are going to be an over approximation. And over here, I'm going to do a right. So again, I'm going to have 1. I'm trying to make them equal distant as best I can. Sometimes it's easier to start on the right. here I'm going to have an under approximation. Okay, and so I've got some gaps here that I didn't cover, and here I've got some overhang. So here I have an over, and I have here an under. So the true area is somewhere between those numbers. If I could actually calculate what those are, I could figure that out. And I suppose I could. You know that the distance here is 5, right? Excuse me, the distance here is 2, and I divide it into 4 parts. So if I take 2 and divide it by 5, I'm going to get 0.4. So this is 0.4 right here. This length is 0.4, this length is 0.4, this length is 0.4, this length is 0.4. And figure out the height of this, I would put in 0 and I'd get 5, and I'd have 5 for height times 0.4, I believe that is 2. And then I would put in this value, which is 0.4, into here, figure out its height, multiply by 0.4, get a value. And I would do that with every rectangle, and I know I'd have an over approximation. Here I would put in 0.4, and this point right here would be f of 0.4, and I would figure that also. And that, in fact, that's what I'm going to do over here in these. And I've kind of organized a little bit better, and we'll go through and do this right now. So this is what's the width of each rectangle. Well, each rectangle, I'm going to take 2 minus 0, figure out the length of my interval. I'm going to divide it by 5 because I have 5 rectangles, and I get 2/5. And 2/5 is the same as 0.4. So that's the width of each one. What is the height? Well, the height is dependent upon the curve, because I want to go as high as the curve. And I think we're going to do right corner. So my first height is f of 0.4. My second height is f of 0.8. My third height is f of 1.2. Okay, here's 0.4, here's 0.8, here's 1.2. So if I plug that in, that's how high I get right here. And then f of 1.6. And finally I go up to here, and that's f of 2. So I have 1, 2, 3, 4, 5 heights, which I should have because I have 5 rectangles. Each of these heights, to figure out the area of each of the rectangles, will be multiplied by 0.4. So how would you compute the area of each of these? Well, I would have 0.4 times f of 0.4 plus, that's the area of one rectangle, right? My width times my height, 0.4 times f of 0.8 plus, there's my second rectangle, so I'm adding up these, 0.4 times f of 1.2 plus 0.4 times f of 1.6 plus 0.4 times f of 2. So those would be the areas of those. Now, how would I write that in summation notation? Well, let's take a look. First of all, I'm summing up. I is going to equal from 1 to 5. Why? Because I have 5 rectangles. Notice I'm multiplying each of these by 0.4. So I'm going to say times 0.4. Now, what is it? It's going to be f of something. Okay? And it's going to look like this. Notice this is 0.4 times 1. This right here is 0.4 times 2. This 1.2 is 0.4 times 3. This 1.6 is 0.4 times 4. And this 2 is 0.4 times 5. While I is going from 1 to 5, here's I, here's I, here's I, Here's I. Here's I. I is changing. 1, 2, 3, 4, 5. So I'm taking 0.4 times I. All right? So that's what's changing. I'll start with 1. What's going to go in there is 0.4. When I is 2, I'm going to have 0.8. When I is 3, I'm going to have 1.2. When I is 4, I'm going to have 1.6. When I is 5, I'm going to have 2. Now, what's my function? My function is this. So that means I'm going to go one step further, and I'm going to write my sum as 1 to 5. And I'm going to take that 0.4, that 0.4i, excuse me, square it, make it negative, and then add 5 to it, because that's what my function tells me. And then outside here I have 0.4. Alright? So how am I going to compute that explicitly? Well, let's multiply all this out and see what I get here. So I get the summation of I equals 1 to 5. And inside these brackets, I'm going to have 0.4i squared, which is 0.16i squared. It's going to be negative plus 5. And I'm multiplying that by 0.4. So if I go distribute that one more time, I'm going to have a negative 0.064i squared plus 5 times 0.5 is 2. So now I can break it up into two summations. I can have negative 0.064 I equals 1 to 5 of I squared plus the summation of I equals 1 to 5 of 2. Well, this one's pretty easy. It's just 5 2's, which is 2 times 5, which is 10. This is a negative 0.064 times. Now, I squared, I believe, was n times n plus 1 times 2n plus 1 divided by 6. And my n in this case is 5 times 6 times 11 divided by 6. Well, I can do some simplification here. And I have a negative 0.064 times 55 plus 10. Well, I'll go to my calculator and figure out what that is. Negative 0.064 times 55 plus 10. And I get 6.48. So my approximate area, if I use right-handed, I'll get 6.48. That's my approximate area. And I know it's an under approximation because I'm underneath that. Alright, that ends part 2 on these notes.